Hey guys, so in this video we're going to talk about parabolas as conic sections. I realize that you've probably heard of and done a lot with parabolas in the past. The warning I want to give for this is that with conic sections we look at this in just like a slightly different way, so I just want you to be on your toes. I do want to review what we've talked about in the past for parabolas. So hopefully at this point in your mathematical career, you know this equation pretty well. You could graph a parabola from this. You can tell how it's been translated, whether it's opening up and down, all that good stuff. Now, when we get to conic sections, there's actually like a slightly different way that we tend to look at the parabola equation. So instead of viewing it this way, we could just subtract the k and make this slight change to the formula. So this is nothing too crazy, but we want to put the y and the k together and the x and the h together. Okay, and just to kind of remind you, so when a is positive, right, that means the parabola opens up, and when a is negative, that means the parabola opens down. Now, the other thing I want to point out about this, for a parabola that opens up or down, I just want you to appreciate that the x is squared. And I bring that up because the next thing I want to talk about is what would this equation look like if we had a parabola that opens sideways? Okay, this is like almost the same equation. So notice this is x minus h equals a times y minus k squared. So the h and the x stay together, the y and the k stay together. The only thing that's different is that for a parabola to open sideways, meaning opening left or right, the y is what gets squared. So it works very similar to how you would typically work with a parabola, except now just the y is squared, and I'll show you how to interpret all that in a moment. Now, the other thing I just want to mention here is as far as a goes, so if a is positive, the parabola will open right, which is in the positive direction, and if a is less than 0, so if it's negative, the parabola will open to the left, which is the negative direction. So this might seem like a lot of information at first, but let's unpack it and let's just focus on sideways parabolas for a moment. So let's give the domain and range and also graph just the following equations, just so that you kind of have a sense of how this works. Okay, so looking at this equation, I know right away this will be a parabola that opens sideways because the y part of it is squared. Okay, so the vertex of this parabola works in the exact same manner as a parabola that would open up or down. So we actually are just going to take now the opposite sign of the x and the y. So my vertex, which I know I wasn't asked to give, but I do need to know it for this parabola, my vertex is -1, -1. So the nice thing about this form of the equation, if you think back to like the original parabola, usually when you look at this equation, when you're choosing the vertex, it's like, okay, this one has the opposite symbol, but this one does not. I don't know if it's more confusing or maybe it's less confusing, but now if we view the parabola in this format, just in this slightly different way of thinking about it, now it's to find the vertex is just the opposite for both number that's next to each variable. Okay, so let's go ahead and plot that. Here's -1, -1. Okay, so next, if you think about it for a parabola that opens up, since there's no number in front here, normally we would have gone out 1 and up 1 and out 1 and up 1. That was how the up and down parabolas worked. It's the same logic for sideways parabolas. There's no number in front of the y here, so there's no like stretch factor, okay? So what we're going to do is then we're going to open in the positive x direction. So the positive x direction, is that this way or is that this way? It's to this way. So I'm still going to go out 1 and up 1 in each direction. I guess it's going to be up and down 1 and then to the right 1. So this would be how I would get to my next points. And then I just open that way. And again, you know right away this is going to be a sideways parabola because this is y squared. So I think it's easier to state the domain and range after you have the graph drawn. So since we have the graph now, we can easily tell the domain and range. So the domain, remember, is what the x's are allowed to be. So notice I have no x's, no x's, no x's. Boop, my x's start here. So this starts at -1. And then the x's just continue this direction for forever to positive infinity. And then for the range, so it might not look like it, but these are going up and down, and they're just going to kind of keep slowly going in these directions for forever. There's no reason that the y's will be just restricted, so the range in this case is negative infinity to infinity. Let's do just one more example with a sideways parabola. So here's an equation. So I've got negative x equals 3y squared plus 6y plus 2. So notice once again that the y here is squared. So just by looking at this, I might not know how to graph this, but I know this is going to be a sideways parabola because the y is squared. Now, similar to working with, the old equations of parabolas, we're going to have to complete the square on this side to figure out like the optimal equation for graphing. So the first thing that I want to do is I want to subtract off the 2 so that I can just focus on the 2 variables on this side. The next part of this, there's multiple ways that you can handle this. So we need the y squared to just be y squared, not 3y squared. Now, my preferred method of handling this is a little bit different. Like there's multiple ways you can do this. So if you see a different explanation that you tend to like more, that's okay. I just like kind of giving the same explanation over and over. It's fewer things for me to remember. So what I like to do is I like to divide out the number. So let me see, I'm going to divide every part of this by 3, and I'm going to divide this whole side by 3. And the way that I'm going to think about the left side, I'm going to think about this as 1/3. So just having like a 1/3 out in front here. And now I've got y squared plus 2y. Okay, so now that I have this set up, I'm like really just laser focused on completing the square on this side. So my b is equal to 2. So my half b is 1. So my half b squared is 1. And so I'm going to add 1 to both sides. So I have 1/3 negative x minus 2 plus 1 equals y squared plus 2y plus 1. So I'll make a little extra space. And now I can factor this side. So I know that the other side is a little bit of a mess, but we'll unravel it in a moment. And then this is y plus 1 squared. Okay, so now what I want to do is I want to kind of clean up, I guess, and maybe like resolve this side. So I need to get this in. So just to remind you of the format that we're ultimately trying to get this in. So we're looking for this format here. This x minus a number, x minus h equals a times y minus k squared. So we're gonna have to do just a little bit of algebra to get everything in this form. But the thing I really keep in mind, this needs to be x minus a number on one side. And then I'm gonna have a times y minus a number squared. So I've got the y minus the number squared part. So let's keep going. Okay, so what I'm gonna do now is I want to try to get this negative x minus 2 kind of isolated again. So let's go ahead and subtract off the 1 for a moment. And actually what I'm going to do is I think I'm going to take both of these negatives and I'm going to bring them out in front here. So this becomes negative 1/3 x plus 2 equals y plus 1 squared minus 1. And now I can multiply this side by negative 3. And I can multiply all sides by negative 3. So notice I multiplied this part here, this part here. The 3 is not going to distribute in, right? Because there's this squared out here. And if I multiply this, then I also have to multiply this minus 1. So this is one part of the equation. This is another part. This is the last part. Okay, so now I've got x plus 2 equals negative 3, y plus 1 plus 3. Okay, oops, and I forgot the square. Okay, so now I almost have that in that format that I want. The only issue, right, is that this is x plus 2, and then there's like this extra plus 3 out here. So I just want to bring this 3 back over to the other side. So this was, not an exact science in some ways, but we got it done. So the final answer, I'll just clear some space. All right, so the final answer now is x minus 1 equals negative 3y plus 1 squared. So now I've got it in that format that I wanted. So what's my vertex? So maybe you want to pause the video and think about that for a second. So my vertex in this case will be 1 and negative 1. And okay, now what I want to do is I want to recommend you pause video here, you try to graph this, and then you hit play when you're ready. All right, so I'm going to go ahead and just set up my little graph paper here real quick. Okay, so my vertex, we said, starts at 1, negative 1, so right here. Now, which way is this parabola going to open, to the left or to the right? This is a negative number in front here, so it's going to open to the left. So I'm going to go out 1, and then I'm going to go down 1, 2, 3 in each direction. So that'll end up being a stretch factor on the x's, so I get something that looks like this. Now, of course, if you weren't sure about what points to use, I've talked about in other videos like how to kind of determine this stretch factor, so it's a similar logic here. If you're not sure, there's a lot of different ways that you can kind of handle this. So if you want to talk through the options, you can always reach out to me and we can go through it. But hopefully, you kind of understand how the logic when you're going to the side kind of applies to, it's the same thing as when you have an up or down parabola. Okay, so we also need to talk about the domain. So the domain is what the x's are allowed to be. So my x's are starting over here. So this is the negative infinity direction. And this goes all the way until boom, right here. So the domain goes from negative infinity to 1. And the range, well, it might not look like it, but this thing is going to the left and to the right for forever. So there's no reason that the range will be restricted. So the range is just all real numbers. So now that we understand that parabolas can open sideways and we understand a little bit more about those equations, let's examine parabolas from the perspective of conic sections, which was, the point of this video. So I want to show you the geometric definition of a parabola. This is a set of points in a plane equidistant from a fixed point and a fixed line. And I just want to mention here, so the fixed point is the focus and the fixed line is the directrix. And so now I'm just assuming that you're reading this and saying, what? Right, so it's a very compact definition, but it's actually very precise. And this is how a lot of mathematics works, by the way. When we really get under the hood of a lot of things, they have very compact definitions that can be a little difficult to read. But once you unpack them and you do the work to unpack them, they're actually very, it's almost like an art in being so precise. So I have a lot of appreciation for it, obviously. So I'll just throw that back up there in case you need to copy it down. You can pause the video if you need to. Okay, so focus, directrix. This is what I'm talking about. So believe it or not, from a geometric perspective, and working with conic sections, so this is actually all that makes a parabola, is the distance between these two things. So distances. So here's my vertex for this parabola. And so you're going to have the distance from one point to the focus and then the distance from that point to the directrix. Now, the line to the directrix is always going to go straight down. The line from the focus to that point can be slanted. But these two distances have to be the same. That's what this definition is trying to say. So for the vertex, it's easy to visualize this, but let's carve out a couple other points just to help you understand this. Okay, so here's another point. So I have this distance here. So here's the distance from the focus to the point, and then the point to the directrix. These two distances are the same distance. So this is the only point on this side that has that exact same distance from here to here and from here to here. That's what we're looking for. So there's another point. And we could do the same distance on the other side, so just kind of the mirror point. So these are this is the only point that fulfills this condition that this distance and this distance has to be the same. And then let's see, if I wanted to do two more, here's another point, here's another point. So again, just assume each one of these distances, this distance equals this distance. So it's a pretty technical definition, and it's a kind of hard definition in some ways to wrap your head around. But if you continue this pattern and carve out every single point that fulfills this criteria, then you get this parabola. So this is another way of how we think of the parabola. And from a geometry point of view, i.e. like from a sketching or pictorial view, this is what makes a parabola what it is. It's not the equation, it's this set of points with these certain relationships between the focus and the directrix. So this is just a different way to think about things, and it's important to be able to think about the same thing from different perspectives. So now that we've talked about the construction of a parabola from this new perspective, let's also examine another way to think about the equations of a parabola. So we have the vertical axis of symmetry, which means that the parabola is going to open up or down. So check out the equation for this. X minus h squared equals 4p times y minus k. And before I talk about what that p is, I want to just contrast this to the horizontal axis of symmetry, meaning the parabola opens right or left. This is y minus k squared equals 4p times x minus h. Okay, so this is the new equation we're going to use for parabolas when we're talking about conic sections, but it doesn't look that different from how we opened this lesson, right? There's a couple things that are a little weird, but you've still got the squared term. So if the x is squared, that still means the parabola opens up or down. If the y is squared, that means the parabola opens to the left or to the right. Now, something that is strange about this, right, is that we have this 4p. If you just compare that to the original equations, we had a number that fell in front of the squared term. So it's just a different context of how to think about things. And so we do this all the time in math, actually. Depending on the context, we might change the equation. And it's just to help us think through that equation in a slightly different context. It makes it easier, okay? So this 4p is now in front of the non-squared term. So you're going to have to maybe make some note cards to help you memorize this. So let's talk about now, what is this P? So HK is still the vertex. That still works the same like a normal parabola. And then the focus is going to be this distance, absolute value of P from the vertex. So I just want to show you a little visual to go alongside of this. Let's just use an up and down parabola for a second. So here you've got your parabola. So something that's been in the background that you weren't aware of was that the parabola always opens up around its focus, and it's kind of being reflected away from its directrix. So these things just kind of have always existed. You just didn't know. And so where that P falls in, this distance from the vertex to the focus is P. And remember, this distance here and the distance from this point to the directrix have to be the same. So if this is a distance of P, then this is also a distance of P. So I'm bringing this up because understanding the construction of these drawings, this is the only way to kind of get through these conic sections. You have to understand what the pieces of these equations mean, particularly for the next type of exercise that we're going to discuss. So what I want to do is, in this next set of exercises, I really want to get our hands dirty now with all these new terms. So we're going to give the focus, directrix, vertex, and axis of symmetry, and also graph the parabola. So the way that we do all of this is we kind of do it in pieces. So I'm going to show you how to construct all of this. So let's start with the equation x squared equals 4y. Okay, so first of all, just what type of parabola is this? Does it open up, down, left, or right? Well, notice that the x is squared and this entire equation is positive. So we can tell just by looking at this that this is going to open up. Now, the next thing that we have to deal with is this number in front of the y. That's giving us actually a lot of information. And so just to bring back those equations we were looking at before. So instead of having a y minus k, I just have y. So my k must equal 0, by the way. So I have this 4p. I know that this is kind of invisibly in front of the non-squared term. So what I'm going to do is I'm going to say that my 4p, what's in that position? It's just 4. So what that implies then is that this p is equal to 1. Okay. The next thing I want to do that I can easily get from this equation is the vertex. The vertex in this case is 0, 0. There's no number attached to the x or to the y, so I can just assume that the vertex is 0, 0. So now what I want to do is I want to note that 0, 0. And now I can also come up with my focus and my directrix from this little piece of information here. So, okay, P equals 1. So remember, from the vertex to the focus, that is the distance of P. So if I started here at 0, 0, then where is my focus going to be? It's going to be right here. And what is that point? That's the point 0, 1, right? And then if I can go this direction to find the focus, I can go the opposite direction to find the directrix. So now I'm just going to go down 1, and I've got this invisible line here for my directrix. So what is the equation of this line? This is y equals -1. This is what I mean by like kind of just sketching things out and figuring it out as you go along. I really think that that's the easiest way to do this. Okay. So now that we have all of this, we really have actually enough to sketch like a rough parabola. So it's going to be a parabola that opens like this, goes in this direction. And from this, I can also tell what my axis of symmetry is. So I know we haven't reviewed that, so I can just quickly review that right now. The axis of symmetry is the line, the invisible line that goes through the vertex that perfectly cuts the parabola in half. So my axis of symmetry is going to look like this. And so this is the line, in this case, x equals 0. Okay. And so that was all the information that we needed. So let's see, I'll summarize that here. Okay, so this is an example where you have the vertexes 0, 0, which is a little nicer to work with. So let's look at something that's a little tougher now. So the first thing I want you to do is read over this equation and determine which direction you think it opens, up, down, left, or right. So in this case, the y is squared and the entire equation is positive. So I can say that this equation then is going to open up. Or sorry, oh my God, opens right. Since the y is squared, it's going to open to the right. Okay, so it's going to open to the right. And then what is the p going to be equal to? Well, in this case, what's in the 4p place is this 24. So I can take my 4p equals 24, divide both sides by 4, and I get my p equals 6. Cool. And then what is my vertex? So you can tell just by looking at this. The vertex is going to be 3, 2. So you just look at what's next to the x and what's next to the y. 3, 2 is going to be the vertex. Okay, so at this point, we want to graph this. We want to start graphing this. So, okay, so I've got a little graph set up here. So my vertex is 3, 2. So here we go, 3, 2. And remember, my parabola now is going to open to the right because the y was squared. The entire equation is positive, so it's got to open to the right. Okay, so here's my vertex. I'm going to count out the focus. So I've got p equals 6. So from here, I can just count out from this point. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, right here. There is my focus. So I can just read now what the coordinates of this actually are. So let's see, 3, 4, 5, 6, 7, 8, 9. So this is 9, 2. There's my focus. Now the directrix is going to be found going the other way. So I'm going to go 1, 2, 3, 4, 5, 6. So here's the directrix. Now, remember, the parabola is opening up this way. So the directrix in this case is going to go this direction since it's a sideways parabola. So what is my parabola going to look like? It's going to look something like this. So we've got a rough sketch and we can figure out everything else from this. And we can also figure out, here's my axis of symmetry. So my axis of symmetry then, this is the line, let's see, this is the line y equals 2, and for my directrix, this is the line x equals -3. So let's summarize that information. There's everything that we just covered. Okay, so this video is getting a little bit long, so I think I'm going to cut it off here, and I will catch you guys in the other video where we will talk about one other topic, which is writing the equation of parabola.